This video is about the dependent t-test. The dependent t-test, the name already says it, is used when you have dependent data. This is the case when you have a within subjects design, in which all test subjects experience all conditions. It could be, for example, that there is a pre-measurement for, then an intervention or treatment, and then a post-measurement, na. And this is the example that we're going to work with. So in an independent t-test, you compare the mean of one group with the mean of another group. And in the case of a dependent t-test, we are interested in difference scores. And we want to know the difference between the pre and the post measurement for each test subject. Therefore, the null hypothesis is not that the mean of one group is equal to the mean of the other group. For dependent t-tests, the null hypothesis is that the difference score equals 0. This is indicated with a D with a bar on top of it. The D stands for difference, the difference score, and the bar indicates that it regards a mean, the mean difference score. The null hypothesis states that there is no difference, that the mean difference score equals 0. The alternative hypothesis states that the mean difference score does not equal 0 in the case of no specific expectation. It's also possible that we expect the difference score to be greater or smaller than 0. To test the null hypothesis, we have to calculate the test statistic. Because we are doing a t-test, this test statistic is t. T is calculated by taking the mean difference score and comparing it to the mean difference score from the null hypothesis. This is usually 0, but it could also be that you want to know if the mean difference score differs from, let's say, 10. In that case, you will enter 10 here. However, in our example, the null hypothesis states that the difference score equals 0, so we can enter 0 here, and this term will disappear. We divide this by the standard error. The standard error is the standard deviation divided by the square root of n. You've calculated the standard deviation before. You can also request it in R, but I'm going to do it manually and calculate it for you. In the formula of the standard deviation there are usually a couple of x's, but we now work with d, so we want to know the standard deviation of d. So where there are x's now, we fill in d's. If we want to calculate the t in our example, we first have to calculate the difference score for each test subject. And to do this, we subtract the post-measurement of each test subject from his or her pre-measurement, or vice versa. Which of these two options we choose doesn't matter. The only difference is that we will either get a positive or a negative D, and therefore also a positive or a negative T. Now, if you have a specific expectation, you should of course check whether the mean difference score is in the right direction. And in this case, we will subtract the pre-measurement from the post-measurement. We then get 9 minus 4 is 5, 8 minus 3 is 5, 3, 4, and 3. We can calculate the mean of these different scores, and we then add up all the scores and divide them by the number of scores. In this case, we would be getting 5 plus 3 plus 4 plus 3 is equal to 20. We have 5 scores, so 20 divided by 5 is 4. And now we have the mean difference score, and we will subtract the 0 from the null hypothesis from this score and divide it by the standard error. The next thing we will have to do is calculate the standard deviation. And for this, we need the d-scores, which we now have, and we will subtract the mean d from these scores. So we will subtract 4 from all d-scores. Well, 5 minus 4 is 1, 1, minus 1, 0, and minus 1. And next we have to square these deviation scores. In this case, that's easy because 1 squared equals 1, minus 1 squared also equals 1. To calculate the sum of squares, we add all these values together, and that's 4 in this case. And we now have the numerator of this fraction, but not the denominator. That is n minus 1. You have to pay attention here because you could make the mistake to think that n is equal to 10. However, we have examined 5 test subjects twice, so we have 5 test subjects in total. Apart from that, we are working with the difference scores, D, and as you can see, we have 5 D values. So in this case, n is 5 and not 10. 5 minus 1 is 4, so we divide the sum of the squares, which is also 4, by 4. Therefore, the answer is 1. We now have the variance, but we still have to calculate the standard deviation. We do this by calculating the square root of the variance. The square root of 1 is, of course, also 1. Now we have enough data to be able to calculate the t-value. And for this, we take the mean difference score, which we can find here, and this equals 4. And next, we subtract the difference score from the null hypothesis from the mean difference score. The null hypothesis states that this score is 0, so we can calculate 4 minus 0. We divide this number by the standard deviation, which we have just calculated, divided by the square root of n. N is equal to 5, so this is 1 divided by the square root of 5. If we continue on calculating, we will see that 4 minus 0 is 4, and 1 divided by the root of 5, you can use your calculator for this, of course, is equal to 0.45. And then 4 divided by 0.45 is 8.95, and this will mean that the t-value is equal to 8.95. In order to subsequently determine the p-value, the probability value, we are also going to need the number of degrees of freedom. And the number of degrees of freedom equals n minus 1, so in this case 4. And with this calculated t-value and the number of degrees of freedom, we have enough data to be able to look up the corresponding p-value.